estimation of endurance strength. Estimation of endurance strength for any member or workpiece or वर्कपीस। किसी मेंबर या वर्कपीस का एंडोरेंस स्ट्रेंथ कैसे फाइंड किया जाए। ओके, सो फर्स्ट ऑफ ऑल there will be material, and for the material sigma ut will be given to you. Sigma ut will be given to you. Okay, so this will be our first condition. First of all, check what is the sigma ut for the material. Then for the same material specimen, स्पेसिमेन समझते हो, स्पेसिमेन सोम में बताया था। स्पेसिमेन के लिए स्पेसिमेन मीन्स हाईली प्रेसाइज एंड मिरर फिनिश्ड, हाईली प्रेसाइज एंड मिरर फिनिश, बहुत ही अच्छा सरफेस फिनिश होगा। That is called a specimen. So specimen are costly. Okay, so for same material specimen you will check the value of sigma e dash endurance strength, and it will be generally equal to 0.5 of sigma ut, 0.5 of sigma ut. So this will become same material specimen endurance strength, but endurance strength of workpiece will be different, because workpiece is not highly polished, its surface is rough, there are little cracks, there are what to say, not accurate dimension. Okay, reliability is not up to the mark. So endurance strength depends on all these things. So for the workpiece, now same material workpiece, or you can say member. For that you want to get endurance strength. So this endurance strength will be lesser than the endurance strength of the specimen, because specimen is very highly polished, as sigma E will be given by Ka, Kb, Kc, Kd into sigma E dash or the point. So this will be your formula for endurance strength of the material, where all these factors are having different significance. First of all, Ka, where Ka will be your surface finish factor. So this value will be given in question generally, surface finish factor. Kb will be your size factor. It will be accounting the dimensions. Dimensions are not generally accurate. Third will be reliability factor. Further, we also learn the reliability in later chapters. There we will see what is reliability. For now, you can see that all these factors will be actually less than 1. And Kd will be equal to 1 by kf, 1 by kf, where kf is a new factor, where kf is a new factor. Its name is fluctuating stress factor. Fluctuating stress factor, or it is also called fatigue factor, or it is also called fatigue factor. So this will be the case. Now, how to find the value of this fatigue factor? Fatigue factor, तो इसका हेडिंग डालो, हाउ टू फाइंड द वैल्यू ऑफ फटीग फैक्टर. KF. So KF, it is the ratio of endurance strength without notch upon endurance strength with notch. So write down, it is the ratio of endurance strength of any workpiece without notch to the endurance strength with notch. Endurance strength with notch. So it will be the ratio of without notch over with notch. Without notch over the with notch. Now tell me, which will be more, without notch or with notch? When strength will be more? There is a notch present on the member and without notch. So which will be more? Bolo, bolo. Which strength will be more? Yes, without notch strength will be more. Yes or no? With notch there will be stress concentration. Okay. So this Kf will be actually more than equal to 1 like this generally. More than 1 generally. Okay. So with notch, let's say this is a specimen. ये चलो अभी लिख दो, इसकी भी बात करते हैं. Now Kf is also given by second thing. Kf is also given by second thing. Write down here. It is also given by Kf equals to sigma max ka star divided by sigma naught in case of fluctuating loading, but this will be for static loading. Static loading, still it will remain more than 1. More than 1. ठीक है, इसको समझो जरा. Let us assume there is a member like this. Let us assume there is a member like this. This is a member. Now on this member let us assume that P1 load when we will apply, P1 load when we will apply, then the stress P1 in static load, then the stress will reach here sigma yt, then failure will start. Yes or no? Failure will start. Now, in second case, let's say this bar is become the stepped bar. Let's say this bar is become stepped bar like this. This bar is become stepped bar like this. So when it will become a stepped bar, then its strength will reduce. It will fail at P2 load. Failure will start at P2 load and P2 will be less than P1. Failure will start at P2 load where P2 will be less than P1. Why? Because here the stress concentration factor will come in picture, KT. KT will come in picture. Got the point or not? Now on this stepped bar, again its strength will come down. Again its strength will come down if I apply here P3 load. These both are static. If I apply here P3, and P3 is your fluctuating load. So if I apply P3 even less than P2, then failure will start. Yes or no? Then failure will start even at a load lesser than this. Then the next case, even the strength will go further down. Even the strength will go further down if there is presence of notch on this. Presence of notch on this. So when notch will be there, then Kf factor will also come in picture. Yes or no? Kf factor will also come in picture. Got the point or not? Then even at a load of P4, failure will start. Failure will start. Okay. So in all four cases, the required load P will decrease. P for failure will decrease. As P4 less than P3 less than P2 less than P1. Yes or no? Or strength of the member will decrease. Will decrease. will decrease. Let's say in fourth case it will be sigma E star. In third case it is sigma E. In second case, let's say it is sigma YT star, and in first case it will be sigma YT. Got the point or not? So this is the case. So the strength of the member will be decreasing. Here the stress produced in the member will be P by A. Simple. Here the stress produced in the member will be here sigma 1, here sigma 2. Sigma 2 will become your sigma nominal. And if Kt is given, then here even sigma naught will not be there. There will be sigma maximum star. Yes or no? This stress will produce due to Kt. Now if load will become fatigue, then even Kt is present, but the actual maximum stress will not be here the fatigue stress. It will be more than this. Sigma max star in case of fatigue, and that will be given by this. That will be given by this. Sigma maximum star in case of fluctuating loading will be sigma nominal of static loading into Kf, if Kf is given to you. Got the point or not? Clear हुई बात? And then if notch is also present, then the notch sensitivity Q will also come in picture.